going to review our lesson today from class about exceptions to Mendel's principles. And the first two exceptions we talked about today were incomplete dominance and codominance. So a quick review, we have been talking about Gregor Mendel so far and his three principles, and the main part of complete dominance of one allele over the other. And so in Mendel's complete dominance, one allele dominated over the other. So a heterozygous condition, like right here in purple flowers, the dominant allele still overshadowed or overpowered the recessive allele, which was white. Now, if we take a look at exceptions to that principle, it was when it was discovered that in some cases, the heterozygous phenotype did not show neither the dominant or recessive characteristic. An incomplete dominance, if you think about the word incomplete, thinks it's not done. So really, the red is not dominant, the white's not dominant, a new phenotype is created, and in this case, it's pink. So when you hear of when you're looking at this and you're reading a question and there's a new phenotype that's created, it's a hint that it's an incomplete dominant situation. So the heterozygous is showing a new color. If you take a look, there's two different ways to write this, and one way is to use the superscript. And so the C is standing for color, and the superscript is actually representing the alleles. Personally, I found that it's too many letters, gets too confusing for students. So if you just use the capital letters, you'll notice there's no lowercase because nothing's recessive in this case. Two of the same letters for red, two W's for white, and then an RW for pink. So again, that's incomplete dominance. We talked about codominance, and you think of like co-captains on a team, they're sharing a role. The heterozygous, both phenotypes are expressed. And this is an example of the AB blood group in which both antigens are present on a red blood cell. All right, we will get to multiple alleles and sex-linked in a future lesson. I'm going to just show the examples that we talked about in class today that go in your note packets. And if you take a look, we're working with snapdragons again, and the white would be big W with a red snapdragon, big R, and really the R is the red allele and the W is the white allele. And if you take a look at the first generation of that combination, they all are pink or RW. If you take two of those pink snapdragons and you mate those, you would end up with 25% white, 50% pink, and 25% red. If you would take, and we represented that over here. So if you want to take a look, that's kind of going over into this Punnett square here. I take that back. I apologize. We actually made this one. We actually did this pink and this white flower. If you cross those, now here's the Punnett square. Here's the pink flower right here, and here's the white flower. And you notice that the offspring are now 50% pink, 50% white. And again, we know this is incomplete dominance because there's a new phenotype. The other examples that we went over is codominance, and I try to remind students that there's a shared, or you can see both phenotypes, chickens, white chicken, black chicken, and a speckled chicken. So if you see what I mean by seeing both colors, this isn't a gray chicken, it's speckled. You can see both the black and white phenotype. And we also took a look at cows, white, red, and then the codominant is roan, represented with RW. And let students pick to mate a red bull with a roan cow, and the possible offspring were 50% were red, and then 50% were roan. Notice none were white. So, challenge yourself here to think, okay, what if we wanted to get all roan cows? What cross would we make? So bring that to class with you on the next class that we meet.